Welcome to the course on social network analysis once again, and today we will discuss chapter 4, which is on network analysis, particularly link analysis. So far we have looked at how we can measure a network from different perspective in chapter 2. In chapter 3 we have seen how we can generate synthetic networks which actually look like a real world network, and there we have observed that when a network is formed, when an edge is formed, that's not random, right? It's not, I mean, the random graph model that we discussed in the last chapter, the real world network actually doesn't follow a random graph model, right? Random network model. So edges are not formed in random. There are some ways, some systematic ways through which edges are linked between nodes. And we have seen in case of, say, Barabasi-Albert model, Price model, this kind of models, that edges are basically formed based on something called preferential attachment, right? When you basically want to join a particular network, you may want to choose a node which is already of high degree, for example, or already has high prestige. Okay, so now the important question is, how do we quantify an edge? Okay, can we come up with different ways to quantify edges, again from different perspective, and can we see how these edges can be useful for other applications, right? Of course, in chapter 6 we will talk about link prediction, which is definitely an application of edges, right? But link prediction is basically, it is more of a recommendation system. But if you think of network and edges, right, when you quantify edges, what are the other things that you can actually infer? Okay, can we say that, okay, look, these nodes are of high importance because of these edges, or when we measure importance of nodes, right, we should look at these edges, not this set of edges, and so on and so forth. PageRank is something that we discussed, and if you remember PageRank formulation, PageRank systematically looks takes into account edges, the directions of edges, right, and then basically prestige moves from one node to another node through edges and so on and so forth, right. So in this chapter, in this link analysis chapter, we will basically try to learn various ways to characterize a particular link or edge in a network. We also connect the network science domain with the social science theories in general, and then we apply these concepts in various other applications. Okay, we also try to quantitatively measure the structural properties of a network via different edge connections. We will learn how networks, how links and edges help in measuring importance of nodes in a network. We will discuss PageRank. We will discuss again in a different manner, right? We will discuss DivRank, SIMRank, and different other ranking mechanisms that you can think of based on the importance of edge. And we will also look at, we will deal with heterogeneous network, where we will see edges are of different types, nodes are also of different types, and then how can we use heterogeneous networks for, say, ranking purposes. We will discuss something called meta path, right, which looks like a path but in the context of heterogeneous network, right. We will discuss all these concepts in this particular chapter. So it's basically, I mean, if you think of network analysis, it is basically a study to visualize a network in terms of links, right. So and node, of course, when we look at nodes, right, vertices, we try to quantify the importance of nodes in a network. We always take into account the links, because links are ultimately entities which basically measure right, an importance of a node, or it basically help you understand that how certain prestige flows from one node to another node and so on, right. So what are the links? So we have already discussed in the chapter 2 that links can be of different types. It can be an undirected edge, or link can be a directed edge, right. When if you think of an undirected edge, it's basically a two-way directed edge, and it can also be weighted, right? This weight of an edge basically quantifies how important that edge is. Now, importance can be quantified in different ways. For example, in case of flow, information flow, importance can be the amount of information that have moved between two nodes through this particular link, right? In case of citation, for example, say citation network between authors, the weight of an edge indicates the number of citations that an author actually gave to another author, right, through scientific papers. Interestingly, edges can also be signed. Okay, sign here means it can be positive edge, it can also be a negative edge, or it can be a neutral edge, right? So what do we mean by a signed edge or a positive edge, right? So when I say that, okay, look, there is a link between A and B and the sign is positive, it basically means that A and B have friendship relationships, right? For example, in case of friendship network, right? In case of say election networks where nodes are individuals who actually vote, and I mean, nodes are of two types. One types of nodes are individuals who vote for certain candidates, and other nodes are essentially the candidates themselves, right? So then in that case the link indicates whether an individual votes for a particular candidate or against a particular candidate, and so on, right? You can also think of links and signs in case of, say, e-commerce network, right? When you review some e-commerce products, right? You can write positive reviews, you can like the product, you can dislike the product. So like corresponds to positive edge, dislike corresponds to negative edge. In say platforms like YouTube also, you can like a video, dislike a video, right? Platforms like Opinion, Slashdot, there you actually specify your friends or your enemies explicitly. Okay, so we'll discuss whole bunch of things on signed network. In general, when we talk about a network, it is in general unsigned, undirected, but depending on the situation, it can be signed, directed, and weighted, right? And we have seen in the last chapter that the dynamics of link formation is not random. There is always a preference based on which links are connected to different nodes, and because of the connections, because of this preferential attachment, right, you can think of emerging communities or emerging clusters. For example, when we see a network actually exhibits homophily kind of property, where nodes are connected with each other based on some sort of common properties, right, common characteristics, right? And in that kind of setting, we'll see that the communities, right, clusters will emerge. We'll talk about community analysis in the next chapter, in chapter 5. And we will discuss in this chapter something called strong ties and weak ties. So strong ties or strong links are those links which actually connect nodes with high similarities, right? Whereas weak ties are those edges which actually connect nodes which do not interact frequently. For example, say if you think of again user interaction network, so the close friends, right, the colleagues or school friends, they interact with each other quite frequently, so they are basically connected through strong ties. Whereas a student from one school is connected to student in another school through weak ties, or an individual in one company is connected to individual in another company through weak ties, because they do not interact with each other quite frequently. Now we will discuss here in this particular chapter that weak ties play a very important role in many aspects. For example, we will see in the next chapter that weak ties are important to detect community structure, right? Because when we break these weak ties, the clusters of a graph actually emerge. In case of information flow also, weak ties play an important role, because essentially weak ties connect different components of a graph, different communities of a graph. And if you want to spread one information from one community to another community, you choose an edge which act like a weak ties, bridge, right? So we discussed all these concepts in the last few lectures: bridge, articulation point, and so on and so forth. Okay, so now look, if you think of applications of link analysis, right, apart from link prediction that we will discuss later, link analysis can be useful for searching purpose, right? We will discuss PageRank algorithm once again, DiviRank algorithm, where links play an important role. And ultimately, when we use PageRank, we essentially use it for what? We basically use it for ranking nodes, right? And ranking nodes is basically useful when we search something. For example, you type a query Harry Potter, right? Now, this particular term is present in many web pages. So how do you rank web pages? How do we rank relevant pages so that users will the user will find the relevant web pages at the beginning and the non-relevant web pages at the end, right? Now ranking plays an important role. So you can think of PageRank here and say you already measured the importance of nodes, importance of web pages based on PageRank, and some query comes in. You just fetch all the nodes which are relevant to the particular query, and then you rank them based on the PageRank. You already have you have already got the rank, so then you use that ranking to arrange web pages on the user feed or search feed, right? This is useful for scientific article ranking, because if you also again think of PageRank on the citation network, right? PageRank is a very simple measure, but you can think of more sophisticated ways, again based on links, and you can also rank scientific articles, right? Either in general or with respect to a certain field. Okay, you can say that okay, let's look at PageRank and let's use PageRank to rank all the scientific papers in a citation network. And then you and then given a particular field, say AI, right? You retrieve all the papers related to AI, and you then rank those pages based on the PageRank. Okay. Similarly, you can rank scientific authors, right? Researchers. Researchers are again connected through citations. Researchers can also be connected through collaboration, for example, and then you can invent your own ways, right, to measure the importance of authors, again based on links, and then you rank them. Anomaly detection, we will discuss later that this link analysis plays a very important role, very crucial role in anomaly detection. So when we talk about anomaly detection, fraud detection, say counter-terrorism, terrorist detection, some usage of this in say police or military services, right? We will see that certain links, in general, most of the links are normal, right? In the sense like they actually connect nodes of similar types, right? Of course, some of the links can be weak links, some of the links can be strong links, but there are links which basically connect nodes of a completely different properties, for example, right? And those links are suspicious links. So link prediction, link analysis is also useful in case of say transaction network, where edges indicate different transactions, right? Say between seller and buyer, and it may happen that some of the transactions are fraud, right? So how can we come up with metrics to quantify again edges or links based on the extent of fraudulent activities, right, with respect to links? Again, we will discuss some of the quantities in one of the chapters. It is useful for mining new patterns, because ultimately, say if you think of motifs, right, three node motifs or say 4 node motifs, right? Ultimately, it's a pattern mining approach, right? You try to mine, you try to analyze the network and try to come up with structures and substructures which do not frequently appear, for example, right? It can also be a part of anomaly detection, but in general, finding out new patterns from a network would be very useful for link prediction, for again, some sort of market research, crime prevention and so on. Links are very important to attack a particular network. Now, what do you mean by attacking a network? So think of a network, right? And assume that you want to you have some algorithm to detect the communities of a network, right? Now your task is to add or delete edges, right, or nodes in such a way that the community detection algorithms start performing badly. So you are attacking a network, you are disrupting some structure of a network. In this case, the structure is community structure. You try to disrupt the structure of the community structure of a network with the modification of network. Now, people may ask that it's very easy because you keep on adding edges, right, between two communities, for example, and automatically the inter-community edges, right, that will become sparse and sparse, and that will become dense and dense, and as the inter-community edges, the inter-community portion become dense and dense, it would be difficult for a communication algorithm to detect communities. Okay, but it's not that easy because you are not allowed to add links or add edges or delete edges, right, as per your choice, because adding an edge actually incurs some cost. Think of a social network, right, say Facebook friendship network. Adding an edge means what? Adding an edge means you are making a friendship between two users, right? So you have to motivate, you have to convince these two users to become friends, and that's costly, right? So and therefore you can think of it as an optimization problem where you have a budget, right, and every addition or deletion of an edge incurs some cost, right? So within the given budget, how can you manipulate the network by adding or deleting edges so that with minimal change in the network structure, your purpose will be fulfilled. Your purpose in this case is to disrupt the community structure, right? That is more from a, you can think of it more from a attacker's point of view, right? Say you are an attacker and you want to attack the community detection algorithm or the network structure itself so that the algorithm starts performing badly. From a defender's point of view also, this is very important because let's say you already have an algorithm for detecting clusters, right? And you had to release the algorithm publicly. So all the attackers know that this algorithm is used for community detection, right? So attackers will start attacking your algorithm, your network, right? Now you are a defender, right? So you also want to add or delete edges so that attackers will not be able to figure out which edges and nodes have been added or deleted, right? At the same time, they also get fooled, right? Because what they would do, they would again run the algorithm, and let's assume that the attacker is very smart, the attacker knows the entire network structure, right? So attacker will run the clustering method, community detection method, right? But you know that these edges have been added, okay? Therefore, the algorithm will definitely perform badly on the attacker side, right? So attacker will not be able to understand the actual community structure, okay? Now, here is the same question. People may ask that since you have complete control on the network structure, you can basically keep on adding edges and automatically the attacker will not be able to detect the actual cluster because because that is trivial. But here again the catch is you can't add edges randomly, or right, you can't add multiple edges because when you start adding edges, the attackers are smart. They also understand that these edges should not have formed here, should not have been there, right? But these edges are there, therefore there is some problem. They will definitely understand it. So here the idea is how you can systematically add or delete edges into the network so that the attacker will not be able to identify the modification. At the same time, they also get fooled. Okay, this is a very interesting topic these days, which a lot of research communities in network science have been working since last 2-3 years. So, in the next chapter, in the next lecture, we will start discussing on sign network. We will discuss different properties. We will discuss something called balance theory and status theory, and we will try to relate, because this part is more of a social science kind of part. We will try to relate the social science part of it with the network science part of it. Okay, thank you.